Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through the answers to the revision sheet. The title of the revision sheet is the same as what's on your screen here. Year 10, Semester 2, Week 5. Core means we're just doing the normal Year 10 stuff, not the 10A stuff, and video because I'm going through it on this video. So let's start with question 1. So for question 1, we had to expand this expression here. So you can either do it the quick way or by using FOIL. Now this is monic because it's just an x in each bracket. Coefficient is 1. So the quick way we can use, we have x squared. The coefficient of x is minus 7 plus 3, which is minus 4. And the constant term is minus 7 times 3, which is minus 21. And we're done. We could also arrive at the same answer using FOIL. So if I take this expression and use FOIL, remember the acronym F means first, so I go x times x, which is x squared. O is outside, so that would be x times positive 3. I for insides, minus 7 times x. And then L means last. So the thing occurring last in each bracket is minus 7 times positive 3, which gives minus 21. So these are the like terms here. So 3x minus 7x gives you minus 4x, and you can see we have the same answer whichever way we do it. Obviously the first way is quicker, but you can choose which way works for you. Let's go on to question 2. So to do this one, expand 2x minus 3 squared, I could use FOIL again. It'll just be 2x minus 3 times 2x minus 3. Then I go through the process. I'm just going to show you the quick way. So the quick way with perfect squares is you square the first. So 2x all squared gives you 4x squared. You square the second. So minus 3 squared is positive 9. What goes in the middle is 2 times negative 3 times 2x. Double the product of the two terms inside the brackets. So 2 times negative 3 is negative 6, times 2x is negative 12x. And that is our final answer. Let's go on to question 3. Once again, we could expand this expression using FOIL, but there's a quicker way to do it. So this is the difference of two squares. We've got the same two terms in each bracket. Just one has a plus, one has a minus. So all we do here is square the first, square the second, and stick a minus between them. How easy is that? So let's go on to question 4. So what we have here are 4 terms, and we're going to factorize them by grouping in pairs. Of course, factorize is the opposite of expanding. So when we're expanding, we start with brackets, end up without brackets. Now we're going the opposite way. Start with no brackets, end up with brackets. So grouping in pairs means I will factorize the first two separately and then the last two separately. So if I just look at the first two terms, x squared plus 4x, so they have a highest common factor of x. So what do I times by x to get x squared? X. What do I times by x to get positive 4x? That's positive 4. So that is the first two done. Now let's look at the second two. So here, there's a highest common factor of a. So it's positive a. What do I times by a to get ax? It's x. What do I times by a to get positive 4a? And that's 4. So now we can factorize again, because we sort of have one thing and another thing. And they both have a common factor of x plus 4. So we're just going to use the highest common factor method again. You write the highest common factor out the front. So what do I times by x plus 4 to get this? Obviously, that's x. What do I times by the highest common factor to get this? That's obviously a. So you can see this and this go in the second bracket, and we're done. So if I were to expand this using FOIL, I would get this. All right, let's start a new slide and start at question 5. So for question 5, I'm going to factorize 7x squared minus 28. So this might look like difference of two squares, but it's not quite, because 7's not a perfect square, nor is 28. But they both have a common factor of 7. So first I'm going to use highest common factor is 7. What do I times by 7 to get 7x squared? What do I times by 7 to get negative 28? Now I'm not done, because what's in the brackets here is difference of two squares. So I can factorize this further. So I've still got my 7. So to factorize what's underlined in black, difference of two squares, two brackets, square root the first, square root the second, 1 gets a plus, 1 gets a minus. So if you expand this using FOIL, you get that. How easy is that? Let's go on to question 6. So now we've got to factorise fully x to the power of 8 minus 1. So it may not look like it, but this is the difference of two squares because this is a perfect square and 1 is a perfect square. So the reason x to the power of 8 is a perfect square is because x to the power of 4 squared gives you x to the power of 8. So let's use difference of two squares. Square root the first, and that goes in both brackets. And then you square root the second. Square root of 1 is just 1. 1 gets a minus, 1 gets a plus. Now, I can't factorise this any further. You can't factorise a square plus another square, the sum of squares, but we can factorise this. It's also difference of two squares. So, let's do that. So, square root of x to the power of 4 is x squared. So, put that in each brackets. Once again, the square root of 1 is 1. So, I'll put 1 in each bracket. 1 gets a plus, 1 gets a minus. And I've still got my other bracket that couldn't be factorised. So we're not quite done yet. This can't be factorised, this can't be factorised, but this here is clearly the difference of two squares. So I'll leave the first bracket alone. I'm going to factorise x squared minus 1. So, get my two brackets, square root the first, square root the second, 1 gets a minus, 1 gets a plus, and I leave my bracket from before that couldn't be factorised. Okay, we're done. We've written it as the product of 4 factors. I can't factorise any of those factors further, so I leave it as it is. If I were to use FOIL and expand all this, I would eventually get that. All right, let's move on to question 7. So for question 7, we are factorising and then solving this equation here. So we need to factorise the expression here. It's monic, quadratic, so what we need to do is find two numbers that multiply to negative 28 and add to give positive 3. So if you don't know what they are, go through factors of 28. Now because this is a negative 28, one of the numbers must be positive and one negative. So after going through factors of 28, we should see that the numbers are minus 4 and positive 7. Because minus 4 plus 7 gives 3, minus 4 times 7 gives negative 28. So once we've got here, we use the null factor law. We have something times something is equal to 0. So either the first something is equal to 0, so if x minus 4 equals 0, x equals 4, or the second something is equal to 0. If x plus 7 equals 0, then x equals minus 7. And we're done. We have two solutions. There's obviously going to be no more. Let's go on to question 8. So for question 8, we have the equation 3x squared minus 5x plus 3 equals 0. And we're asked how many solutions. So the number of solutions it has is totally determined by the discriminant, which is b squared minus 4ac. Remember, if the discriminant is positive, there are two solutions. If it's 0, there's one solution, and less than 0, there are no solutions. So in this case, a is the number in front of x squared, b the number in front of x, and c is the constant term. So it's b squared. You must, when you're putting it in your calculator, put the negative in brackets. B squared minus 4 times a times c. So that is 25 minus 36, which is minus 11. So the discriminant is negative, and that's enough to say there will be no solution to this equation. There's no number you can substitute for x to make this equation true. All right, let's start on a new slide at question 9. So for question 9, we're going to solve this equation here using the quadratic formula. So as I told you, always start with the discriminant. So b squared minus 4ac to tell you how many solutions. So here b is 11, a is 4, and c is 7. So if you put that on your calculator, you should get the number 9. So because the discriminant is 9, it's positive. There will be two solutions. Because 9 is a perfect square, they'll both be rational. So let's go ahead and use the quadratic formula. So this is the quadratic formula on your screen. You will get it during the test, so you don't need to memorize it. So we're going to substitute b. So in this case, b was 11, so I changed that to negative 11. Now the stuff under the square root is the discriminant, b squared minus 4ac. So I just figured out that that was 9. So I'm just going to change that so it says 9. And then on the bottom, we have 2 times a. So in this case, a was 4, so we change this to 2 times 4. So there are 2 solutions here. Now, of course, the square root of 9 is just 3, so one solution is minus 11 plus 3 over 2 times 4 is 8, and the other solution is minus 11 minus 3 over 2 times 4, which is 8. So minus 11 plus 3 over 8, that's just minus 1, minus 11 minus 3 over 8 is negative 7 over 4, or minus 1.75. Either way you write it is fine. They are the 2 solutions, and as we predicted, they are rational. All right, let's go on to question 10. So here we have the sum of the squares of 2 consecutive odd numbers is 290. What are the 2 numbers? This is a worded question, so we always start by defining our variable. So we'll let x be one of the numbers, in this case the smaller number. Now we don't want to let y be the other number because we don't want 2 pronumerals. We only know how to solve quadratics with 1 pronumeral. So if x is the smaller number, x plus 2 will be the larger number, because if you have an odd number, you add 2 to get to the next odd number. So once we've defined the variables, we just turn the worded information into an equation. So what it's saying is the first number squared plus the second number squared is equal to 290, and we're going to find what x is. So of course what we need to do, we're going to first expand the brackets, so square the first, square the second, and what goes in the middle is 2 times x, or 4x. So we need to get one side equal to 0, so first collecting like terms, and then what we're going to do is subtract 290 from both sides. So we get 2x squared plus 4x minus 286 is equal to 0. So now that we're here, you can use factorization or the quadratic formula. Because we're using big numbers, it's probably easiest to use the quadratic formula. So that's what I will do. So the discriminant is equal to b squared minus 4 by a by c, which gives us 2,304. So that's positive. There'll be 2 solutions. We get x equals minus b plus or minus the square root of the discriminant over 2 times a. In this case, a was 2. So if you put that on your calculator, first solution, minus 4 plus root 2,304 divided by 4, that gives you the solution x equals 11. Minus 4 minus square root of 2304 over 4 gives you the solution minus 13. So we're not done. X was the smaller number, so the 2 possibilities for the smaller number are 11 and minus 13. So if the smaller number is 11, the larger number is 13. If the smaller number is negative 13, the larger number is negative 11. So they're the 2 possibilities. The numbers are either 11 and 13 or negative 13 and negative 11. Let's go on to question 11. So the length of a rectangle, 12 centimeters more than its width. The area is 64. What's its perimeter? So you have to think to yourself, what do I need to know in order to find the perimeter of a rectangle? And that's, of course, its dimensions, its length and its width. So that's what we're going to use quadratic equations to solve. So let's let x equal the width of this rectangle. So if x is the width, the length, we don't want to introduce another pronumeral, it'll be x plus 12 because it's 12 centimeters more. So the area of the rectangle is width times length, and we're told that that equals 64. So now you know how to do this. We expand the brackets and we need to make one side equal to 0. So when you get to this point, you can once again use factorization or the quadratic formula. I'm going to use factorization. 2 numbers that multiply to negative 64 and add to 12. So that will be negative 4 and positive 16. So what that means is the 2 solutions are 4 and negative 16. However, because in this occasion x is the width of something, we can't have a negative width. We reject that solution and we conclude that x equals 4. So that means the width will be 4 centimeters and the length 16 centimeters. So we should end it with a worded answer saying therefore the width is 4 centimeters and the length is 16 centimeters. And so the perimeter is 2 times 4 plus 2 times 16, which is of course 40 centimeters. Okay, so I know I'm not the best role model here. Please make sure in the test you answer a worded question with a worded answer. Let's go on now to question 12. So let's look at this question here. The perimeter of a rectangle is 48 centimeters, area 108 centimeters squared. What are its dimensions? So once again, we're finding the length and the width. So let's let x equal the width. Now, if the perimeter of a rectangle is 48, that means that the length plus the width add to 24 centimeters. So that means the length would be 24 minus x. We don't want to introduce another pronumeral and let the length equal y. We write it in terms of x. So the width plus the length adds to 24. So the area of this rectangle will be width times length, and that equals 108. So once again, we're going to expand the brackets. Now we need to get one side equal to 0. It might be easiest to take this and the 24x over to the other side because the x squared here is negative. So let's start by adding x squared to both sides. And then we're going to subtract 24x. So we get 0 equals x squared minus 24x plus 108. So we can solve this by factorization or quadratic formula. With a large number, might be easiest to use the quadratic formula. So let's do that. Discriminant equals b squared minus 4 by a by c. So if you put that on your calculator, you get 144. So of course this is positive, there will be two solutions. 144 is a perfect square and thus both solutions will be rational. So using the quadratic formula, x equals minus b, so minus 24 is positive 24, plus or minus the square root of the discriminant over 2. So we have 24 plus 12 over 2, which is 18, or 24 minus 12 over 18. So they're the possibilities for the width. So if the width is 6, the length is 18. If the width is 18, the length is 6. They are the two dimensions. So you should end off with a worded answer. Therefore, the dimensions are 6 centimeters and 8 centimeters. Let's go on to the final question now. So for our final question, we're given a formula for the number of diagonals and finding how many sides a polygon has with 170 diagonals. So n is the number of sides, d the number of diagonals. We don't need to define a variable here. All we're doing is finding what is the value of n when d equals 170. So substitute d for 170 and we have this equation here. So what we can do now is expand the brackets. So we get 170 equals n over 2 times n gives you that. N over 2 times 3 just gives you 3n over 2. Now here, it's probably looking a bit different because there are some fractions. So let's get rid of the fractions. Let's times each side by 2. So if I times 170 by 2, I get this. If I times n squared on 2, I get this. And if I times 3n on 2, I just get 3n. So I've multiplied each side by 2. So once again, I want to get one side equal to 0. So I get 0 equals n squared minus 3n minus 340. And again, I solve by factorization or the quadratic formula. Now again, because we have a big number here, it might be easiest to use the quadratic formula. So let's start by calculating the discriminant. So it's b squared minus 4 by a by c. Once again, squaring a negative, make sure it's in brackets in your calculator. So that gives you 1,369. So let's solve the equation. It doesn't matter that there are n's instead of x's. We'll do this the exact same way. So we will have n equals minus b, so minus 3, positive 3, plus or minus square root of the discriminant over 2 times a. In this case, a is 1. So the square root of 1369 is 37. So we have 3 plus 37 over 2, which gives you 40 over 2, 20, or 3 minus 37 over 2, which gives you negative 17. So once again, n is the number of sides of something, so we need to reject the negative solution. You can't have negative 17 sides. So now we figured out n equals 20. That means that the polygon with 170 diagonals has 20 sides. Doesn't even matter if we don't know what diagonals are. All right, best of luck with your studying. Please let me know if anything didn't make sense. This has been the luckiest maths teacher in the world. Have a great day.